Okay, hello students. In this video, I will solve an example about how to apply the theorem of angular momentum, or another way, Newton's second law in rotation. Now in this example, we have a homogeneous disk, mass 20 kilogram and radius 10 centimeter, rotates with a constant speed 900 revolution per minute. Revolutions per minute. At t equal to 0, the disk is subjected to a braking couple of constant moment m, so that the disk stops in 5 seconds. So initially the disk was in motion, means it has initial angular speed, right? Okay, we want to determine the moment of the couple. Let's start. Here our disk, okay, this is our disk, which is full here, okay. Now we want to determine the moment. We have to apply, as you know, the theorem of angular momentum, or what we call, also this is called Newton's second law, because we have rigid body. Only because we have rigid body. So sum of moment is equal to d sigma over dt, right? Or equal sigma prime, and also equal I theta double prime. Let me displace this here. Okay, good. So for the disk we must have I equal, this must be given in the exam, okay, half m r squared. Okay, now if you do the calculation, we have the mass and we have the radius, you get 0.1 kilogram meter square. Okay, now what are the forces acting on the disk? Here is the axis of rotation, delta, passing through the center of the disk. This is what? Delta. And let's suppose that the disk is rotating like this, theta prime, sorry. Here is theta prime. So the disk is rotating, say, clockwise. Now what are the forces acting on the disk in reality? There are its weight. Let me use the color red. The weight of the disk, which is what? W or mg. And the reaction of the axis, because here there's a pin. You know this. This is called the axis, which is a nail or a pin. Reaction R. But don't forget, the disk at t equal to 0 is subjected to a braking couple of constant moment. So to stop the disk or to break the disk, the couple must be like this. This is the moment of the couple. You can write it like this: moment m b, braking. Okay, this is the braking moment. Now you know that moment of weight, moment, as in the previous example, and as you did in back 1, moment of weight equal moment of the reaction. You know this is equal to 0. Why? Why 0? Because both forces intersect the axis of rotation. Okay? So we have only the moment of the couple, moment of the breaking couple, and it is opposite to motion, so it is negative. This means that moment of the breaking couple, I prefer to write it like this, equal what? Replace in this rule, sigma prime, right? So antiderivative now implies antiderivative. Also you can say I theta w prime and you calculate theta w prime, no problem. But since I am working with angular momentum, I prefer to use always the rule of angular momentum. So make antiderivative. This is constant. What is the antiderivative or primitive of a constant? It's like this. Minus moment of the couple. This is time. But this is not enough. Because you know from mathematics, when you make integration or antiderivative, you have to add the constant here, right? And you know this constant C is sigma, but the initial value, initial sigma. Don't forget the disk was rotating, right? This is the initial speed of the disk. So we can calculate what? Sigma, right? So it means what? I have two things. We have to determine two things. Sigma, you know that initial sigma is equal I, and this is a general rule, right? I theta w prime, don't forget, theta prime, sorry. But initial angular momentum, initial what? Speed. Remember, that's the angular momentum of the rigid body. Here it is. Here. This is the angular momentum of the rigid body. Okay? So I have to find I, let me change the color, I equal half mv squared. We have just calculated it, 0.1, and theta prime, which must be in radian. And you know that theta prime is equal to 2 pi times number of revolution per second initially. Okay? So let's calculate this. Theta prime initial is equal 2 pi. Now we are given that the initial angular speed of the disk is 900 revolution per minute. First of all, we must change minute into second, right? So it becomes 900 divided by 60. Why 60? Because 1 minute is 60 seconds. Now try to do the calculation, 0 here with 0 here, and you get 30 pi. What's the unit of theta prime now? Radian per second. Okay? Good. Now if you replace, then you get moment of the couple, moment of the breaking couple, when of course, but wait a minute here, at t equal 5 seconds, what happened to the disk? The disk what? Stops. Disk stops. What does this mean? What does it mean, stops? Stops means its angular speed becomes 0. It means what? It means its angular momentum becomes 0. Now try to replace in this rule. Here it is. Here is 0 and time is given 5. Also we have calculated this 30 pi, I think. So we can calculate moment. This will imply the moment of the breaking couple becomes sigma 0 over I. Okay? Now if you replace everything, you get 1.88 Newton meter. Okay? Any problem? Now part B. In part B, not here, here. Calculate the number of revolution. We want to calculate the number of revolution made by the disk during the breaking time. What is the value of the breaking time? It is what? It is 5 seconds. Okay. To calculate the number of revolution, we must know the angle. Why? Because each revolution corresponds to an angle. What is the value of the angle? 360 degree, right? One revolution, 360 degrees. And equal what? 2 pi. In physics, we use what? The radian. 2 pi radian. Now I want the number of revolution, and here it is, question mark. What is the corresponding angle? Theta. Okay, so this means that and equal theta over what? 2 pi. It means that to calculate n, you have to know the angle theta, but in radian, right? Okay. But theta double prime from part 1 is equal minus moment of the couple over I. It means it is constant and negative. So what is the nature of motion? Uniformly decelerated rotational or circular motion. Let me call it circular motion. So I can apply this rule. In this case, theta equal half theta double prime t squared plus theta prime 0 t plus theta 0. Okay, you can put theta 0 0 as an initial abscissa 0, or you can say here delta theta. Okay, so we calculate delta theta. We have everything. Just replace theta double prime from here, and you have the time 5, you have this, so we can calculate delta theta or theta, doesn't matter here, is equal theta minus theta 0. It's like delta x in rectilinear motion, okay? Equal 236 radian. Now replace in this rule here, as we verified it, n equal theta or delta theta over 2 pi. Then you get n equal 236 over 2 pi. 2 pi means 6.28. Approximately you get 37 0.5